Hello, in this video I'm going to talk about how you can solve quadratic equations using factorization. What you see here on the screen is actually an example from a previous video on how to plot the graphs of quadratic equations. And so you can see this is the graph here of y equals x squared minus 3. And in the example below you can see it's another quadratic equation and with a nice parabola, and in the graph below that, or in the problem below that, we have the equation f of x equals x squared plus 3x plus 2. And you can see for this particular example I solved this equation using factorization, wherein after factorizing this quadratic equation we're able to find the roots, or the two solutions for the equation, which in this case is x equals negative 1 and x equals negative 2. And in the table of values that we created, we also found x equals negative 1 and x equals or at x equals negative 1 there is y equals 0, and x equals negative 2 y equals 0, which gave a big hint that that's where our solutions were. And indeed we found out after we graphed the equation that that's where our two solutions, or our two roots, our two real roots, happened to reside. Okay, they just basically, this graph comes down and doesn't cross the x-axis, it mostly just kisses these 2 points. Alright, so the reason I'm showing this graph is because it's important to keep in mind when we start working on factorization, or we start thinking about how to factorize quadratics and how to solve quadratics using factorization, I should say. So let's start with a very simple example. Say that we're given x squared equals 9x. So the first thing that we're going to want to do here is we're going to want to subtract 9x from both sides. Alright, so what we're left with is 9x, or x squared minus 9x equals 0. And now we can factor out an x, that's a common factor, and so that will leave us with x times x minus 9, and all of that's set to equal 0. And if one doesn't already understand what's going on here, I have other videos on factorizing, basic introductory videos on how to factorize. But in this case, x can equal 0, so that's one solution, x can equal 0, or x minus 9 equals 0, and we just add 9 to both sides because we want to solve for x, wherein then x equals 9. Okay, so those are our two solutions. X equals 9 and x equals 0. Those are the two roots. So let's do another one. And if you were to graph this, it would be the same as what we found in the previous example that I just showed before I started working on this problem. Its roots would lie at where x is 0 and x is 9. Okay. Can do another one and say, for instance, we have x squared minus 2x minus 15 equals 0. So one might recall that the general form of a quadratic is y equals ax squared plus bx plus c. Okay, so that's a, there's b, and there's c. Well, to the first step, there are different approaches on how to factorize quadratics. And when I am given an equation like this, I immediately think of AC. Okay, so AC, A times C, that's A, that's B, and that's C. A is just 1, right? The 1 is in front of this x term, it's implicit, so 1 times negative 15. So A times C equals negative 15. Now you want to think what multiplies to negative 15 and adds to negative 2. Okay, well 1 times 15 would give us 15, but that's not going to help us here. 3 and 5 certainly multiplies to 15 and would add to 2. We need to add to negative 2, so we're going to make this 5 negative. Okay, so it's going to be 3 plus, oops, I should write that, 3 plus negative 5 equals, 3 plus negative 5 equals negative 2, and 3 times negative 5 equals negative 15. So these are our two factors. So we can rewrite this equation. We can say x squared plus 3x minus 5x minus 15. All of that set to equal 0. Now we can factor out an x from this pair of terms, and we can factor out a 5 from the next pair. So that will leave us with x plus 3. And we can say minus 5, and then that's x plus 3. Okay, all of that set to equal 0. Now we can factor out one of these x plus 3 terms, and that's going to leave us with x plus 3 and x minus 5. And now we just need to solve for x for both of these, okay, because they're both set to equal 0. So x plus 3, right, which is set to equal 0, or x minus 5, which is set to equal 0. And so we're just going to subtract 3 from both sides, which will leave us with x equals negative 3. And in this case, we're going to add 5 to both sides. Therefore, x equals 5. And those are the two solutions, the two real roots for this equation. And if you were to graph it, which I could do, but for the sake of saving time, I won't. But if you were to graph this, you would see that the roots, the two solutions, lie at x equals negative 3 and x equals 5. I'll do another example. Yeah, say for instance, let's do, say we're given that 6x squared, say we're given 6x squared plus 13x minus 5, okay, equals 0. Again, we want to immediately look for AC, right? A times C. That's going to be 6 times minus 5, which is going to give us negative 30, right? Now we need to find what multiplies, it's negative 30, and adds to B, which in this case is 13. So, well, 1 and 30 is not going to help us. That won't add to much, or even close to 13. But if you think of 2 and 15, well, 2 times 15 equals 30, and we need it to equal 13, so, and it needs to be negative 30, so we're going to say it's negative 2, because then negative 2 plus 15 is going to equal 13. So those are our two factors, two terms, and so now we can rewrite this equation as 6 squared minus 2x plus 15x minus 5, which is set to equal 0. So in this first pair of terms, we can factor out a 2 and an x. So that's going to leave us with 3x plus or minus 1. And for the second pair of terms, right here, we can factor out a 5 plus 5. That's going to leave us with 3x minus 1, right? Because if we were to distribute this 2x back in, we would end up with 6x squared minus 2x. Again, if we were to distribute this 5 back in, it would be 15x minus 5. And now we can factor out a 3x minus 1. So that's going to leave us with 3x minus 1 and 2x plus 5. Now we need to solve for x for both of these, so we're going to set them to equal to, well, they're still set to equal 0. Okay, so we need to solve for x here, and 2x plus 5 equals 0. So for the first one, we're going to add 1 to both sides, so that's going to leave us with 3x equals 1. Now we divide by 3 both sides, so we isolate our x because we want to solve for x, and that's going to mean x equals 1 over 3, okay, 1/3. Likewise on this side, we're going to subtract 5 from both sides. That's going to leave us with 2x equals, equals -5. We want to divide by 2 both sides, so we isolate our x, because again we're solving for x, so it's going to be -5 over 2. So those are our two roots, our two solutions. X equals 1 over 3, x equals 5 over 2, which, I mean, you could also say -5 over 2, which is also -2 and 1/2, right? So it's fairly straightforward. I'll do another one. I might do a few videos on solving quadratics using factorizations, just so there's a good mixture of problems. I will also do videos on completing the square and on how you can sketch graphs of equations, solve problems using the discriminant, and also using quadratic formula. And those are actually really handy, because not all problems you'll find that you'll be able to factor quite a few equations, but some equations, quadratic equations, second degree polynomials, it'll be very, very difficult to factor. Some can be very difficult, and some are it's not possible to factor them. So that's where other techniques become very, very useful as well. But I'll do one more example here where, for example, say for instance, we have x minus 3 squared equals 7. So the first thing we can do here is we can take the square root on both sides. Okay, so that will cancel this out, so we'll end up with x minus 3 equals plus minus the principal root of 7. Now we can just add 3 to both sides, because again we're solving for x, we want to isolate the x on the left side here, and so that would we're adding 3 to both sides, so it's going to be 3 plus or minus the principal root of 7. So our two solutions in this case is x equals 3 plus root 7. Okay, I'll box that off. Or x equals 3 minus root 7. So here are two solutions, and if you were to plug those into your calculator, you would get a decimal value, which you could then plot on the graph if you were to graph this. So yeah, that's overall it's fairly straightforward. I will do one more example. Let's say, yeah, I'll try one more example. Say we are given 4x squared plus 17x, which equals 6x minus 2x squared. So for this, we just want to basically subtract 6x on both sides. We want to add 2x squared to both sides, right? Minus 6x and plus 2x squared minus 6x and plus 2x squared. And the reason for doing that again is we want to rearrange this. So what we end up with is 4x squared plus 2x squared. And see this plus 2x squared plus 17x minus 6x equals 0, because 6 minus 6x, that's just going to cancel out, and that's also going to cancel out. What you do to one side you have to do to the other, right? It's our basic rule. So this we can so we're left with all of this. We can simplify. 4x squared plus 2x squared is 6x squared. 17x minus 6, that's 11x. So we're left with 6x squared plus 11x, and we can now factor an x out. Actually, I'll rewrite this just so it's a little bit more neat. Plus 11x equals 0, that's what we're left with. Common factor, we can factor out an x, so it's going to leave us with x times 6x plus 11. Now, so our two solutions, x equals 0, that's 1, right? Because it's outside the brackets, so x equals 0. And the other solution, so it will be, it will be 6x plus 11 equals 0. We're going to subtract 11 from both sides. Again, it's just basic algebra. So 6x equals negative 11. We divide we divide by 6 both sides, isolate for our x. That's going to be negative 11 over 6, and we can't simplify this anymore. So these are our two solutions.